Okay. Hello. Hi. Today we'll introduce the next part of our topic on the calculus for full. Right. So thus it is a continuation from our previous classes. So calculus for full part 2, right? Okay. So recalling from our previous demonstration, from our previous findings actually, so just from previous classes we'll end it off with the crucial findings or a crucial formula. So if y is x power n, actually relation between x and y such that y is equals x power n, then the dy over dx goes to nx power n minus 1, right? It is our previous calculations. Okay, now today we actually we'll proceed from this thing. So if y equals to 10x, then what will be the values of dy over dx, right? If the x depends on y in such a way that y equals 10x, then what is actually dy over dx, right? Okay. So you changed x, little bit of new x becomes x plus dx, right? That is the new x, and by the change of x, then according of our relations, y should change and the new y becomes y plus dy. It is new relationship. Okay. Okay. And it's an old relationship. Old. Okay. Now, if you just plug in it here, instead of y, just write it y plus dy, and instead of x, just write out x plus dx. Then the new equation becomes y plus dy equals 10x plus dx, right? Okay. And what is this? This is just a product, the simple product. All of you know this, right? So 10x plus 10 dx is the y plus dy. What is 10x actually? It is in our just old relationship, y equals 10x, and instead of 10x you can write the y plus 10 dx. It is the y plus 10. So you can cancel out y and y. So dy equals to 10 dx. So what is dy over dx? It's very simple. Dy over dx goes to just a 10 to 1, right? The 10 actually, 10 into 1. Bring to actually the 10 into 1 means 10, right? Okay. So if y equals to 10x, then the dy dx goes to 10 into 1, of course is just 10. Okay. Okay. Now if y equals to some 100x squared. What is the value of dy over dx? Right. So if y equals to 100x squared, what will be the value of dy over dx? Okay. So the same procedure I will follow. The mu x becomes x plus dx, and by the virtue the changing of x, so y should be changed, so new y becomes y plus dy, right? There is a new relationship, the old. Okay, just plug in it here. Instead of x, you can write out x plus dx, and instead of y, you can write it simply y plus dy, right? So instead of y plus dy equals 100 into, instead of x, just plug in here. X means the new relations x plus dx here. So x plus dx whole square, right? And all of you know what is this thing. This is 100, and is a x squared plus dx squared plus 2x dx, right? And obviously from our previous class, all of you know what is this thing actually. It goes 0, because the smallest thing. Okay, so now we left out 100 into x squared plus 2x dx, and these are y plus dy. What is this? 100 into x squared plus 100 into 2x dx, these are y plus dy, right? And what is actually 100x squared? It is our old relationship, y equals to 100x squared. And obviously, instead of 100x squared, you can write it y. So y plus 100 2x dx is the y plus dy. So obviously, you can cancel out. Here is y and y. And now, so dy equals to 100 into 2x dx. So, what will be dy over dx? Is just 100 into 2x, right? Obviously, it is 200x. All of you know, it's a simple multiplication. So, if y equals to 100x squared, then dy over dx becomes 100 into 2x, right? Okay. And then if y equals to somehow is a minus 21x cubed, then what will be dy over dx? That is simple. It's a simple, very simple. So we'll looking forward in our previous calculations. It is a very simple process. The new x becomes x plus dx and y plus dy. New y becomes this thing. It is a new condition. It is our old conditions. Just plugging it here instead of y, that means y plus dy, and instead of x, just plugging it x plus dx. So what is y plus dy equals minus 21. X means the new x, x plus dx is cube. Okay. So minus 21, and all of you know is the a plus b whole cube. It's x cube plus 3x squared dx plus 3x dx squared plus a dx is cube. Okay. So now the dx squared is the smallest thing and dx cube much more smallest one. So you can cancel out, right? Okay. So now we left out minus 21 x cube plus 3x squared dx, right? Is that y plus dy. And if you just, this is actually your distributive rule, just product it out. Minus 21x cube and the minus 21 into 3x squared dx, and it is a y plus dy. Okay, and obviously minus 21x cube means here is a y actually. Just instead of this thing, the minus 21x cube, you can write it y. So it's a y, and y and y cancel out. So you left out dy equals minus 21 into 3x squared dx. So what is dy over dx? Dy over dx means minus 21 into 3x squared, right? So if y equals minus 21x cube, then the dy over dx goes to minus 21x, minus 21 into 3x squared, right? Okay. Now it is a very crucial findings here. What is this? Actually the 10, 100, the minus 21 is actually a constant. It is a number, right? It is a number. And for our calculations, the number doesn't hamper, right? Just doesn't hamper. The 10 here is a 10, is a 100 here, is a 100, is a minus 21 here, is a minus 21. It doesn't hamper. But all of you know, if y equals x, then the dy dx goes to 1, right? So just here is a x, and you should calculate only the 10 should be constant, and what will happen? X, it is just the dy dx is 1, and here the 100 remains constant, and what will be x squared? The dy dx of x squared is a 2x, right? And here minus 21, here is a minus 21, it remains constant. And what will be x cube? If you dy over dx is x cube, then it is a 3x squared, right? So dy dx of here is a, if the y is x squared, then dy dx goes to 2x. If y equals to x cube, then dy dx goes to 3x squared. Okay, see here, x, if there is x, then dy dx goes to 1 here. If y equals x squared, then the dy dx goes to 2x. Is a 2x, just x squared, and if you just dy over dx will go to 2x. Then if y equals x cube, and the dy dx becomes 3x squared, right? So actually the constant doesn't hamper for our calculation, right? Okay. Okay. So actually the constant remains constant in our calculation. Okay. Now what will happen if, so actually I ended up in a formula, if y equals to a and in a constant x power n, So what will happen? Dy over dx. The a remains constant, it is the a, and just y is, if y is x to the power n, and what is dy over dx? It's simple, n x power n minus 1, right? N x power n minus 1. So it is actually a second formula, just a magical formula. If y is equal to some constant into x power n, then the dy dx goes, the a is a constant, should remain fixed, and if you we have x power n, and then if you just count dy over dx, it goes to n x power n minus 1. This is similar thing, right? The second formula of our differentiation. Dy over dx, right? Okay. So now, So now the first formula of dy over dx, if y equals x power n, dy over dx becomes n x power n minus 1. And secondly, just recalculate it here, if y is some constant into x power n, so the dy dx goes to, the constant remains constant, and if y is x power n, which is a dy dx goes n x power n, is x power n, this goes n x power n minus 1, right? Okay. Now what will happen if y equals some 2x cube plus 4x square? What will happen? So the same way I will proceed. If the new x becomes x plus dx and the new y becomes y plus dy, it is a new relationship, right? It's a new, it's an old relationship. And if just plug in it here, the new relations, instead of x, just write it x plus dx, and instead of y, you can just write it y plus dy. Then the new relations becomes, instead of y, you can write y plus dy, and 2 here it is a x plus dx whole cube, and the 4 over x squared means x plus dx squared, right? Okay. So it is a 2x squared, is a very simple formula, a plus b whole cube. It is the x cube plus dx cube plus 3x squared dx plus 3x dx squared, right? And what is the second term? The 4 and is the a plus b whole squared. It's the x squared plus 2x dx plus dx squared, right? Okay. Now obviously all of you know the very smallest thing and the smallest thing, and is the smallest thing. You can cancel out the 0 will be a 0, right? So what equation you get out, right? Is a 2x cube plus 3x squared dx, and then it's a 4x squared plus 2x dx, right? It is a y plus dy. Okay. And then just the product of it is a 2x cube plus 2 into 3x squared dx plus 4x squared plus 4 into 2x dx, right? And then if you just jumble up with 2x cube and 4x squared, and then 2 into 3x squared dx and 4 into 2x dx, just jumble up. It's a very similar thing, 2x cube plus 4x squared plus 2 into 3x squared dx plus 4 into 2x dx. Right? This is actually your commutative law, right? The a plus b means is a simple b plus a, obviously. So you can just use the addition, so you can jump down, right? So what is this 2x cubed plus 4x squared? It's the old relationship. It's the y actually. This is the y plus dy. It's the y plus dy. So obviously it is y because our old relationship is the y. Okay? It's the y. So you can cancel out. Here the RHS part is a y and LHS here is y. So you can cancel out. So now what is dy actually? Dy, okay, so I'll erase some part of this calculation. Okay, I'll just erase some part, right? Okay, so okay. Now the dy goes equal 2 into 3x squared dx plus 4 into 2x dx, right? And all of you know, if you common the two term here, there is a common term dx, right? So if you just common the two term, 3x squared plus 4 into 2x dx, that is dy. So just what it goes in dy over dx. It is just 2 into 3x squared plus 4 into 2x, right? Okay. Now just take a look here. What will happen here? It is the 2 remains constant because our formula here, the a remains constant, 2 remains constant, and the x cube goes to 3x squared, right? Obviously, because x to the power n goes to n, x to the power n minus 1, so x cube goes 3x squared, and the plus remains plus. The 4 is a constant, remains constant here, and x squared obviously goes to 2x, right? Because if you do the calculation of x cube, if you have y equals to x cube and just goes dy over dx, you will get from x cube is just 3x squared, and if you have just y equals to x squared, and if you go over dy over dx, you will get from x squared to 2x. Just 2 remains constant here. X cube goes to 3x squared here. Plus remains plus, the sign actually. 4 constant goes to here the 4, and x squared goes to 2x, right? Okay. Okay, so it is an addition formula of our dy over dx, right? It is the addition formula. Addition, and if you just from here you can just subtract. If you just instead of plus sign, if you goes to the minus sign, so what will happen if there is a minus sign? Let's check, let's verify. If there is a minus sign, then what will happen? Okay, so obviously let's proceed with our same process. With the x, the new x becomes x plus dx, and new y becomes y plus dy. Just plug in it here. Instead of x, x plus dx, instead of y is y plus dy. So the y plus dy here, 2x means x plus dx whole cube. Okay, is a new relationship. I will erase it, right? Okay. So let me write down. Yeah, it's a new. Okay. Okay. So now x is a minus 4, x goes to x plus dx squared. Okay. So another very simple thing, a plus b whole cube, it is a x cube plus dx cube plus 3x squared dx plus 3x dx squared minus 4 into x squared plus dx squared plus 2x dx, right? And obviously it is the very smallest thing in comparison with x. It is obviously smallest thing in comparison with x. And the same, the dx squared, you can cancel out here, cancel out. So let out y, sorry, 2x cube plus 3x squared dx and minus 4x squared plus 2x dx, right? Is a y plus dy. Is a y plus dy. Okay. So now just to product it out, you will get 2x cube plus 2 into 3x squared dx and then minus 4x squared minus 4 into 2x dx, right? Y plus dy. Okay. Now the simple jumping up here. The 2x cube minus 4x squared is a close relationship. So if I write here 2x cube minus 4x cube plus 2 into 3x squared dx minus 4 into 2x dx. What it goes? It is actually a previous relationship, old relationship, y equals to 2x cube minus 4x squared, right? So it is a 0, sorry, it is a y actually, right? It's a y. So it is a y and these y and RHS y will cancel out. So left out an equation which is dy equals to 2 into this thing. Okay, so I will write it here. Dy equals to 2 into 3x squared dx minus 4 into 2x dx. So it is two terms, obviously, this and this, and there is a common term dx. So you can common it out. So 2 into 3x squared minus 4 into 2x over and dx is a dy, right? So what is dy over dx? Dy over dx means the 2 into 3x squared minus 4 into 2x, right? Is a dy over dx. Just look at this thing. It will happen. The same thing. The 2 constant remains constant. 2 constant remain constant. And if y equals x cube, then the dy dx goes to 3x squared. The x cube here, and if there is a dy over dx, it will goes to 3x squared. There is a sign minus. There is a minus sign here. 4 is a constant, remain constant. And here is x squared. And what will be with x squared? If y equals to x squared, then dy dx goes to 2x. So x squared goes to 2x. Okay. So now we can conclude, right? The special thing, if it is plus or minus, if it is plus or minus sign here, because if there is a plus sign, I actually got, if there is y equals 2x cube plus 4x squared, I got dy over dx is a 2 into 3x squared plus 4 into 2x, right? And then if instead of here sign plus, if I plug in the minus sign here, same result, but dy dx goes to 2 into 3x squared minus 4 into 2x, right? Okay. So now it is a very simplest thing. If y equals to 2x cube plus minus 4x squared, so dy dx goes to 2 into 3x squared plus minus 4 into 2x, right? If there is a plus, you will get here plus. If there is a minus, you will get here minus, right? Okay. Okay. So now I will conclude. In general, if y is some a x power n plus minus b x power m, then dy over dx becomes a remains constant here, and for if y equals x power n, the dy dx goes to this thing n x power n minus 1, then here plus minus b constant remain constant fixed, and here is x power m, so x power m becomes m x power m minus 1, right? It is our another general formula. It is the addition and subtraction formula. It is actually a commutative rule for differentiation. It's a number 3, right? Okay. So now I summarized all of this formula. It's a number 1, it's a number 2, it's a number 3 here. If y was x to the power m plus bx to the power m, the dy dx goes to a remains fixed, and x to the power n goes to n x power n minus 1 plus minus same thing. This b remains b x power n becomes m x power n minus 1, right? Okay. Now if another relationship happen, if it is y equals x squared into x cubed, so what will happen? What will happen? Just one way you can proceed is the one process, number 1 process. Just write it y equals x squared into x cubed. It is just your class 8 formula, like laws of index. Just 2 plus 3 is 5, it is x power 5, and dy dx goes to 5x power 4. It is very simple. Or if I introduce here just another formula, right? This is one way, and the second way I can calculate it here. Dy over dx. Okay. First of all, just listen. Just fix it x squared, right? Into here is a into, and now the dy dx of x cube, so dx cube dx plus previously I fixed x squared and just I differentiate it, just calculate dy dx over this thing. Now I will later just interchange this process. I will now fix x cube here and dy dx of this thing. So d of x squared dx, right? Y means x cube here, and here y means x squared here, right? Okay. So how it goes? X cube into, it's very simple. It will becomes 3x squared plus is x cube into it is a 2x, right? So it is a 3x square into x square, x to the power 4 plus 2 here, x cube into x means x to the power 4. So ultimately is the 3x to the power 4 plus 2x to the power 4 goes to 5x to the power 4. The same result actually. So if it is x square into x cube, you will write it y equals x power 5 and calculate dy dx here. You will end up with the result 5x to the power 4. And if I introduce here another rule, if there is a two functions, obviously all of you know what is the functions. I have introduced previous lecture. It's another function. Is another function. Another function. One function remains fixed, and then you dy over dx some another functions here plus. Now here is another function fixed. This is cube, and then you just dy over dx of another functions. So just same result actually here. So now I will introduce a formula here, the product rule of dy over dx, right? It's the product rule. So I write it with a u and with a v, right? So if y equals to u into v is a u and it corresponds v. So dy dx goes to u into dv dx plus v into du dx. It is a product rule for dy over dx. Actually, d dx means it called differentiation, right? It's a differentiation. So actually, so dy dx means actually differentiating of y with respect to x, right? It is actually the original meaning of dy over dx, the differentiating y with respect to x actually. Okay, so now in our next class I will introduce the physical interpretation of dy over dx and the relation between physics and the mathematics of dy over dx, right? Okay.